The EPP 3D made by Red Eagle Models is a great 3D trainer. For a foam airplane, it is quite large. There isn't a whole lot of criticism that I can point at this airplane except for the construction manual. It is very, very basic, and the next video provides a bit of information for those of you who are going to build it to take a bit of the guesswork out of it. For this plane I will be using the Turnigy S1317B servo. It is a ball bearing servo, but it's an economy servo, a nice little cheapie, but it fits within the specifications for this plane. The airplane will be flown using the FreeSky 8-channel 2.4 GHz receiver. I make a point of testing all my servos ahead of time. It is much easier to find out at this stage that the servo or one of the extension leads are not working. Once it's all routed into the airplane, it's difficult to replace it. I always make sure that I tie the servo lead to the servo extension. You can use whatever you like. I like to use dental floss and the type without wax. The reason is that once you tie this stuff, that knot will never let go. To see where the servo must be mounted in the wing, you can sort of get an idea as long as you have a little bit of light from the back. You can actually see the plywood landing plate very well by using a flashlight to illuminate it through the wing. The servo mounting block is a very sturdy piece of plywood. A tiny little potential space exists between the foam of the wing and this little piece of plywood, which means that when you bolt the servo down, the wing is going to deform a little bit. To overcome the problem, I'm going to slide a little piece of wood that I'm going to cut from this popsicle stick into that potential space. This is reasonably easy to do. The space there is just about the right size to allow you to slide it in without any real troubles. There we go, now it's nice and solid. Use a pin vise to draw a guide hole for your servo, that way the wood will not split when you put the screw in. The wing is attached over two carbon fiber rods. They're 23 inches long. To install them, measure it so you can find the middle of the rod, that way you'll have the same amount each side. Then there are these little rings, wooden rings, that help you center it and glue them in place. You can use CA to glue this in place, but make sure you have foam-friendly CA if you're going to touch the foam in any way. I found that normal CA does melt this foam. Before you glue anything, test fit both wings. The two rods go into holes on the wings, and you want to be sure that everything fits well before you put the glue in. Once the glue is dry here and the rods are secure, and also check it for alignment of course, but once everything is dry, put some epoxy over the rods and slide your wing in. That way the wing will be permanently secured. To get the main wing to fit perfectly, a small bit of the foam must be removed on either side of the fuselage. Otherwise the wing will not fit flush. The stab is mounted using two sets of carbon fiber bars. On my aeroplane, the holes drilled in the aluminum was too far forward, which would have meant the elevator would be mounted here, where the aluminum tube is in the way. The fix was easy enough, though. I drilled two new holes 9 mm back from the original holes, and my stab now slides in perfectly with the elevator having plenty of room to move. To mount the stab, I'm going to put some epoxy on these rods and also enough epoxy to catch the aluminum tube so that the stab will be firmly mounted in place. I now have the aileron in place with the supplied CA type hinges. A word of advice here: when doing the aileron, put the CA hinges onto the trailing edge of the wing first before you put them into the aileron. There is a wooden support running along the back edge of the main wing, and it's actually pretty difficult to get the CA hinges to go through that. I had to improvise a bit to get it in. Once it's in, it will be in there very securely because it's actually glued to wood. I used medium foam safe CA to secure all the hinges on the aircraft. Here is the tail wheel, a very basic setup. It simply slides into a tube into the rudder for steering. The only modification I recommend is to solder a washer or use a wheel collar on the wheel mount itself here where it meets the base plate. The reason for that is you don't want any ground impacts to be transferred to the foam rudder, because it'll just break here. This way any ground impacts will be transferred to the base plate and to the wood, and it will be very more durable that way. It's a nice wheel though, with a very nice little spring built into it. Mounting the main gear is very easy. There are 2 holes drilled into the aluminum tube. Each of the main gear struts goes into one hole and actually comes out the other side. The plastic support is glued to the side of the fuselage with epoxy. Make sure you glue this in really strong, because this will take all the impact. Unfortunately, the supplied cable ties broke, 2 of them, so I just used new ones. That's an easy fix though. I suggest using good quality cable ties here, as they are bound to take a bit of a pounding during landing. Here is the mounting for the elevator and the rudder. I had a look online to see where other people had put their servos, and I've decided to put mine as far forward as I can to minimize the need for nose weight. Basically started by putting in the elevator servo first using their push rod. I moved it as far forward as I could, and straight push rod back here. This is a Great Plains clevis that fits onto the control rod perfectly, and then the same on the other side. Once you've got the elevator in, the rudder mounts just in front of that. In order to mount the servo, you have to make a little cutout right through the foam, and then glue this wooden support block onto it. What I've done is to slide the wooden support block right up to the foam here that covers the aluminum tube, and that's where I glued it on, and that's where the cutout is made on both sides. Here you can see the underside of the servo that actuates the rudder. If you do it this way, I have found that you have got a pretty straight line back to the control surfaces, both for the elevator and, as you can see on the other side, a nice straight push rod to the rudder as well. The same thing here. Mount the servos first, as the rudder servo, mount that first. And once you've got it done, you then want to glue in your control horn position on the rudder. A word of caution: remember that the elevator has a lot of movement available right here, and you don't want this control rod to interfere with the elevator. So make sure that it's mounted out of the way here, so it will not obstruct movement of the elevator. A quick and very easy way to get the wires neatly out of the way is to stitch it to the fuselage by running some thread through the fuselage, and it's very easy that way to just tie it and tighten it, and your wires will be neat. The motor mount has built-in right thrust. Make sure when you glue it in that you don't do it upside down, or you will end up with left thrust. It is made from composite plywood, and it's actually a very neat little thing. It should glue in very, very securely. To make sure you can trust your motor mount, saturate all the joint lines that you can see with CA glue before you mount it onto the airplane. The mount has large glue areas to glue it onto the aluminum tube. I glued mine on with epoxy, and I'm not going to put any screws or anything in there. I'm quite sure that this motor mount is not going anywhere at all. Once the mount is in place, you can see that there's a little bit of right thrust into the motor, so the motor will be pointing slightly towards the right of the airplane, which is the correct thrust angle. The manual recommends using a 1000 kilovolt motor. I tested Turnigy's 3542 1000 kilovolt motor, but was not able to get a good amount of watts out of it using a 3S LiPo. Switching to 4S, it would be plenty power for about 100 grams penalty. I would like to fly with 3S LiPo if I can. The 3542 1100 kilovolt motor, also from Turnigy, tests completely different on a 3S battery. I was able to get at 34 amps, 375 watts, which should hover the aircraft reasonably easily because it only weighs 1240 grams. The motor vibrates a bit. Make sure you use a bit of thread locker when you put it together. There are several ways of setting up your equipment. I positioned the ESC and the LiPo on the right side and the receiver under the wing on the left side. The ESC is Turnigy's Plush 60 amp unit. My center of gravity is at 112 millimeters from the leading edge, measured at the base of the wing. The receiver is positioned under the wing inside a piece of foam to protect it against vibrations.
To provide an idea of comparative size, here is the EPP 3D seen next to Hobby King's EPP FPV, which has a wingspan of 1.8 meters, and over here is Hobby King's Pitts, which is also a little foamy. The EPP 3D is a fairly bulky plane. That concludes the construction video of the EPP 3D. I hope you find the information useful. It's now time to go and test fly this one. As soon as I get some flight video edited, I will post that.